her presentation on nano-remediation of water contaminated with metal and metalloid. We're going to start, first of all, to all of you. I want to thank the organizers of this event, especially Dr. Edgar Gonzalez for giving us invitation and allowing us me as part of Mexico to be part of this forum. Thank you, Edgar, very much. And thank you to all of the partners who are here in Colombia and from other countries who are with us today. Okay, first of all, I'm going to talk with you today. It's going to keep on with the same topic, nano-remediation of water contaminated with metals and metalloids specifically. Okay, so you can see this is really fast introduction of what's happening. The problem of the water is local, but it's also a global problem. And you know, if we don't have water, and if you have too much water, it's still a problem for all the countries in the world. In Mexico specifically, we have the two situations. The northern center part of Mexico is totally dry, and the south it has too much water. Either of the cases, we have problems. Why problems? Because it's not just a matter of having water. It's a matter, you know, for our different activities, we need clean water. And to be able to drink, especially the human being. The human being consumes water that if it's not clean, or if it's not a clean water or a safe water, then we're going to have health issues. And we're also going to have problems with different ecosystems. So this situation has been getting worse and worse each day because of different factors, just not only local but also global factors like the droughts, the growth of population, and the more strengthening of water. There's too much demand of water that each day is growing more and more, and this is what is making it also the water as a resource within a situation critical worldwide. It's for this reason, within the objectives of the millennium that were checked in the past year, in 2015, the goals we had globally are now these objectives of the millennium. Are the goals for the development, the sustainable development. And here we see a lot of them. The first one, to finish, how can we eradicate poor people if we don't have water? Within all of these objectives, we have the first main ones is the one with water, clean water, and the sediment. These are not objectives. They're all connected. It's connected directly as with the cities and the communities, the sustainable communities, which is what we want as a goal. But then we also have with the action of the climate, all this climate change that we're having, and how can we, you know, deal with all these goals that we have. Anyways, I just want to mention really fast, because it was mentioned before, the energy that is coming. One of our seventh objectives, which is also a global objective in the millennium, and it's associated directly with water as a resource. Okay, so goal number 6, which is a worldwide goal, it's about to ensure the access to safe water and sanitation for all. You know, because they're both hand in hand. You need to have safe water and you need to have a good sanitation as well. So then, you know, and when you have communities and everything that has to go with the treatment of waters and residuals, industrial residuals and all that, all these different kinds of treatments that are needed for the water, because this is essential in the world we live and essential that we want, and the one we want to live with this resource. So now our objective here is to be able to have access a universal access to potential to safe water. And with these goals, we want each home, each school, each hospital or health system. These are part of the objectives we have for a sustainable development. And you can see that's why this is a global issue. That's why we are here. But then again, if we stop here, if we have safe water and sanitation, then we can relate it to with people that are more healthy, that have a better health. You can have a higher, if you have a better health, then you have more prosperity. You can have societies that are more equal, ecosystems that are also more healthy, more protected, and communities that can go forward and help with these climate changes. And we're in a transition and we're trying to make them better. Okay, so if we go back to our theme, our topic, and talking about drinking water for humans, according to the reports of the UNESCO, we can see here the dark blue is what has been able to achieve in Latin America was practically achieved. But we need to know is what type of water we're talking about. Are we talking about water in the tubes that coming through tubes, water that's disinfected, or are we talking about water that's drinking water? What's drinking water? Well, we all know this. I just want to talk about it again. It's water that's free of microorganisms, without that won't help hepatitis, cholera. We have acute effects if we don't have healthy, without microorganisms drinking water. So we're going to have problems, immediate health issues, 1 month, 15 days, less than a month. We can have an epidemic if it doesn't happen. If it's not also, we also need it to be free of toxic substances. All those organic and inorganic substances that are considered toxic. We don't pay much attention to that because the effects of these toxics are not chronic. They know it's something that happens in the long term, 10, 15 years in the population. They're not going to happen within a month or a week or 2 weeks, like it is in the case of the microorganisms. This is one of the biggest problem we have right now within the drinking water for humans, or water if we want to classify it as drinking water. Yes, it's usually not a drinking water for different reasons. One of the reasons also is the natural contamination. I'm not going to say the anthropogenic one also contributes, but one we had not taken into account was the one that is happening through nature. The natural contamination, like what my speakers before, Roberto and the other teacher, the contamination through arsenic, and here I am adding another one, which the contaminants, which is also associated to arsenic, which is the fluoride. They are natural contaminants, and they're present, and they're still toxic with the same effects that the contamination with the anthropogenic contamination would have. And then, of course, we have all the anthropogenic contaminants with other types of like metals and metalloids, mercury, radius. So all these effects, chronic effects that happen because of the same action it had, it's difficult to identify, and it's difficult to perceive because of through the population. But then we still have to keep them into account. This is the map of the arsenic contamination worldwide. As you can see, this is arsenic 3, this is arsenic 5. They're both arsenics with different levels of toxication, but the result at the end is the same. So if you see, In America, we have a lot of issues with arsenic, just like Roberto just mentioned. The contamination through arsenic in Argentina, in Chile, in Peru. Basically, if we look at it in a detailed way, if we put it with the fluor, here you have, this is the fluoride contamination in groundwater map. It's not all of it. We have a lot of places that we haven't measured it yet, and we still have to be careful and identify them first to be able to establish the different kind of strategies that we want to use. For example, if you see if we look and we have alternatives to be able to mitigate the consequences of this exposition, especially because we all drink water, as easy as that. So we need to identify this and we need to fix it. In the case of Mexico, clearly about the water quality we have, here we have the maps. This is what we have. It's what we have measured till now. Doesn't mean that's all measured. But in a big part you can see how it's affected. We could be more or less the same as Argentina and Chile, the same as other countries, Peru. And here we can see the map of the presence of arsenic and fluoride in the different parts of Mexico. A few weeks ago I was in a meeting in Mexico and they told me we don't have 22 states, we have 32 states where we can detect the presence of the arsenic and the fluoride. Now if we go for the natural, now we're going to go to the anthropogenic contamination, and here it goes a lot bigger, especially in the case of the metals and the metalloids due to the minery and the petroleum refinery. And if we go to the case of the petroleum, Mexico, all this is the area that is affected at the moment. In the case of mercury, which is another one of the contaminants that was directly related, not with the natural contamination, but mostly related to the anthropogenic contamination. We can see here the different scales. The red one is the highest concentration, between 50 and 100 tons freed from mercury. We can see that this is this isn't anything new. The problem with mercury is quite high, and it is also one of the challenges we have worldwide, to be able to take the mercury out of the drinking water so it won't keep on going through the different ecosystems. The reason why in the human we have these chronic health effects, I am showing you here some of the chronic health effects from the arsenic, the fluoride, the mercury. With arsenic, we have it's called declared as a carcinogenic, and it's all related to problems with the nervous system. The same as the fluoride, as well as the mercury. And I'm going really fast to the concentrations to tell you that the nanomaterials can be one alternative precisely, and to be able to get these goals for the millennium, to be able to get them to the access to drinking water, be universal, and through the different processes of treatment. This due to the properties, the physical chemical properties, the nanomaterials are the motor right now of this revolution, of this nanotechnology revolution, and they can contribute directly and indirectly to be able to get to these goals. I don't have much time, so I'm going to go really, really fast to show you the processes for drinking water as well as treating for residual waters, where the nanomaterials are considered as a great opportunity. And these are, as you can see them here, we have the membranes, the different kinds of membranes. As Edgar was mentioning before, we can have special membranes where the nanomaterials are inserted, and in this way we won't free the nanomaterials to the. And then another thing we want is the absorption, through absorption. And then we also have the photocatalysis. And then we can also do a lot of things with disinfecting. And then, okay, so going really fast to the absorption. One of the great disadvantages it has is how do we divide these nanomaterials and how we retain them. This technology is still quite new, and the costs are very expensive still to the conventional, compared to the conventional technology that is being used at the moment. So that's why we want to really work and see how we can introduce them. Here I'm showing you the desalinization through the membranes, and then as you can see, when we include the nanomembranes, we can make the characteristics better, and then with this way reduce the cost and have more volume, a higher volume treated. And Mexico, we've done several studies, and nanofiltration has been the best one. Another aspects that are also important are the challenges, the cost, and how do we reduce the risk as well, and how to introduce this into the market. And as a conclusion, really fast, we want to see that the access to safe water, or to the drinking water for human consumption, would transform the lives of many people in the developing world, because we all drink water, of course. But then again, there's still a lot to be done, and nanotechnology is something that is already being used, and it can be an alternative that we can explore, and then we can pass from the lab to the experiment plants and then to the communities. Thank you very much.